Hi everyone, in today's lesson we're going to talk about how to use long division to divide polynomials. So the first thing we're going to do is revert back to when we first learned long division way back when. So we want to divide 513 by 4. So 513 goes inside and 4 goes on the outside. And now you just want to start the division. So you want to see, well, how many times does 4 go into 5? You should be telling me once. And we put a 4 down there because we multiply 1 times 4. And then we subtract. You should get a remainder of 1. How many times does 4 go into 1? It does not, so we have to bring down the next term, which is 11. Now how many times does 4 go into 11? You should be telling me 2. So then we multiply 2 times 4, that gives us 8, and we subtract and we get 3. How many times does 4 go into 3? It does not, so we bring down the next term, which is a 3. And now we multiply, we'll figure out what times 4 gives me 33, which is 8. And then 8 times 4, which is 32. So we subtract these, and we get a remainder of 1. So this is how we write the problem. That we have, if I wanted to get 513, I would take 128 times 4, and then add the remainder. So let's put that into words. If I want to get this 513, which is called the dividend, I would take the quotient times the divisor plus the remainder. So if you don't trust me, put into the calculator 128 times 4 and then add 1. I guarantee you that will give you 513. So what you just did right there is called the division algorithm. Now if I want to find the dividend, which we'll call p of x, we're going to take the quotient, which we'll call q of x, and multiply it by the divisor, which we'll call d of x, and add the remainder, which we'll call r of x. This is the division algorithm. There is an alternative form to it by simply dividing the entire parts of this equation by the divisor, d of x. Now this alternate form is what we're actually going to use. So basically, if I take any polynomial p of x and divide it by some divisor, it's going to equal the quotient q of x plus r of x, the remainder, over d of x, the divisor. So the reason why this part here was only q of x was because these two canceled. Now I know this is a lot to take in, it's a lot of letters, but just hang tight, we'll go over it more in detail tomorrow. But let's see if we can use long division now. So we want to use long division to divide this by this. So the x minus 2 is the divisor that goes on the outside. We're going to put 6x to the third minus 19x squared plus 16x minus 4. Now just like we did regular long division, we're going to take it one piece at a time. So I want you to focus your attention just on this x and ask yourself, how many times does x go into 6x to the third? Or in other words, what do I need to multiply x by to get 6x to the third? You should be telling me I need to multiply this by 6x squared. 6x squared now, we can multiply by everything here. So 6x squared times x is 6x to the third. Now 6x squared times negative 2 is negative 12x squared. And now just like normal division, after we multiply, we subtract. Now 6x to the third minus 6x to the thirds will cancel. Now this is the tricky part. Negative 19 minus a negative 12. So it helps if you put it into the calculator. I know some of you can do the math in your head, but this is a lot, so it may be a little bit easier. So you would want to put in negative 19 minus a negative 12. So when you do that, you're going to get a negative 7x squared. Now just like in all old-fashioned, we're going to bring down the next term. Now you want to ask yourself, how do I go from x to negative 7x squared? So basically, what do I need to multiply x by to get negative 7x squared? You should be telling me negative 7x. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is a positive 14x. Sorry, I forgot the x here. And now we subtract. So negative 7 minus negative 7 will cancel. And now in the calculator, 16 minus 14. That should give you 2x. Now bring down the last term and ask yourself, what do I need to multiply x to get 2x? You should be telling me 2. And now we multiply. 2 times x is 2x. 2 times negative 2 is negative 4. And we subtract. So 2 minus 2 cancels. Negative 4 minus a negative 4 will also cancel. So we have a remainder of 0. So there's nothing to write except for the answer. And we have to separate it. Our answer is 6x squared minus 7x plus 2. Now those of you that have seen this before, this should be relatively easy. So now I'm going to show you a trick. Whenever my divisor is in x minus a, so x minus a number, you can use something called synthetic division. And it actually gets you this answer up here very quickly. So the way it's set up is instead of the factor coming out here, you put the root here. So if x minus 2 is the factor, the root is the opposite, positive 2. And what goes here on top are all of the coefficients of the thing that I need to divide. So I'm going to put a coefficient of a 6 right here, then a negative 19, 16, and negative 4. So these are the coefficients of the dividend, the 6, the negative 19, the 16, and the 4. Then you bring down the first term, and you get a 6. And then you bring it down, and you multiply. 6 times 2 gives you 12, and that goes here. And then you add. Okay, so negative 19 plus 12 is a negative 7. And now you multiply these two, and you get negative 14. And then you add. So 16 plus negative 14 is 2. Then we multiply. Put that there, and then add. We get 0. That should be my remainder right here. So do you see the coincidence between the 6, this negative 7, and the 2? That's your answer. So the only thing that you have to remember is that these are the coefficients of the quotient, and it's always one less power than the dividend. So if the dividend had a power, if we look up here, if the dividend had a power of x to the third, the quotient is always going to be one less. So this quotient will be 6x squared minus 7x plus 2. So we're just going to write that out just like we did before, 6x squared minus 7x plus 2. Final answer. So I like synthetic division because it actually gets you to the answer much faster, but it only works when you are dividing by something that has x minus a number. It's not going to work for the second problem. So let's go to the back. So this second problem has a divisor of 2x minus 3. So that will not work with synthetic division. So we're actually going to have to do this longhand. So we're going to put 2x minus 3 on the outside. And then on the inside, we're going to put this polynomial function. But what did I have up here? I have used zeros as placeholders. You must include all exponents from the highest degree and continue all the way down to the number. So what do I mean by that? If I start writing this, I have 4x to the third, but I don't have any x squareds. So I have to account for that by putting in a 0x squared. Then I can put the minus x, and then the minus 9. Okay, so let's now continue with long division. So how many times does 2x go into 4x to the third? Or in other words, how do I multiply 2x to get 4x to the third? You should be telling me 2x squared. So now we'll multiply. 2x squared times 2x is 4x squared, or excuse me, 4x to the third. 2x squared times negative 3 is negative 6x squared. And now we subtract. So do you see how if you did not have this 0 here, you wouldn't be able to subtract? So now we're going to do 0 minus a negative 6, which is a positive 6x squared. Bring down the minus x, and now go from there. How do I multiply 2x to get to 6x squared? You should be telling me a positive 3x. So now I multiply. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. And we subtract. These cancel. There's technically a negative 1 in front. So negative 1 minus negative 9 is 8. So this is 8x. And then we bring down the negative 9. And we now say, okay, how many times does 2x go into 8x? You should be telling me 4. So now we multiply. 4 times 2x is 8x. 4 times negative 3 is negative 12. And we subtract. And again, putting this in the calculator, negative 9 minus negative 12 is 3. So we have a remainder. So how did I say we should probably write this? Our quotient, and then this over that. That's what we would write our final answer. So our quotient plus the remainder over the divisor. It's not proper to write this quotient and then remainder 3. We're really supposed to write it this way instead. Okay? This is that alternative form to that division algorithm. Okay? So why don't you see if you could try example number 3 all on your own, and I'll check it tomorrow in class to see that you've done it, and we'll start there. All right, have a great night.